Hello guys, good afternoon, good evening and good morning whenever and wherever you are watching this live video from. Please don't forget to indicate where you are watching from. It's very important we know each other. Where are you watching from? Is it clear? Is it clear? Is it clear? Tell me in the comment section if it's clear. Okay, alright, it's clear. Yeah, it's clear. Reggae Simple Girl from Kenya, how are you, brother man? Laston Sondahai, where are you watching from? If you're watching from Zambia, which province are you watching from? Yesterday we had all the provinces except Muchinga. Is it Muchinga? Except Muchinga. Joyce, welcome back. All right, guys, so we are going to solve this, which is this? 2022 Mathematics Paper 2. All right, Copper Belt. So Copper Belt is in the building. Last time from Copper Belt. Okay, thank you so much. Thank you so much. All right, so let's get started with the first question here. So the first question is saying, express, which is 1a, express 6 over x minus 2 minus 2 over x minus 4 as a single fraction in its lowest terms. And just 3 marks there. Okay, so let's solve it anyway. So this is question 1. Question 1a. Right, question 1a. So this is 6 over x minus 2 minus 6 over x minus 4. Okay, this is 3 marks. Priscovia, how are you? So remember what we've been doing when you're given such a question. You just look at the denominator of this fraction and they're not the same. So what you do is you multiply them by putting them in brackets like this. So x minus 2 and x minus 4 like this. Then here you cross multiply. So just this 6 multiplied by this. So it will be 6 open bracket x minus 4 like this. Then minus these 2 multiplied by x minus 2. Okay? Very fine, Priscovia. So what you can do, have a paper. You should be solving in advance. Okay? In advance, then in the comment your question, your answer, okay, so that we compare at the end of the solving. So 6, so this is going to be We have x minus 2, copy the way it is, x minus 4, like this. Then expand here. So how we are going to expand? 6 times x, this is just 6x. 6 times negative 4 is negative 24. Okay? Negative 2 times x here is negative 2x. Negative times negative is positive. 2 times 2 is 4. Okay? 4. Then this stage you collect the like terms. So this will be x minus 2, x minus 4, like this. Then collect the like terms here. So you have a 6x here. This is negative 2x. So it will come here as negative 2x. The sign, remember the sign doesn't change here because this negative 2x is not crossing the equal what? Equal sign. Okay. So here we have negative 24 plus 4. All right, 6x minus 2x, this is just 4x. Negative 24 plus 4, we have two numbers with different signs, so we subtract and get the number from what? Get the sign from the bigger number, rather. So 24 minus 4 is 20. The sign for the bigger number is negative, so this is just negative 20. Yes, last one, you are correct. Over the denominators, which is x minus 2. This is x minus 4. Then we reach this stage. Okay, check if you have what is common. All right. So you can, if you want, you can also factorize here on top. But let's just end here. Okay, you don't have to waste the time during the exam. All right. Let's go to question B. 1B. This is a calculus question. So we're asked to evaluate this definite integral. We have negative 3 as the lower limit, the upper limit as 2. Okay. Then here you have 4 minus 3x squared, like this, dx. Okay, that's what we are having. So let's evaluate it together. All right. So when you're given such, when you're given this equation, rather, what you do is integrate. What did I tell you? The integration of this constant number. So the constant number here, you just add x. Don't what? Just add what? Add x. All right. Add x. Then this one, we're going to write 3x to the power 2 plus 1 over 2 plus 1. Not going to add plus c because this is the definite integral. So let's just leave it the way it is. So this will be 4x minus 3x to the power 3 over 3. Okay. Now this stage 3 can go into 3. Okay. 3 can go into 3, so we can just remain with 4x minus 3 into 3, just remain with x to the power 3. Okay, then when you reach this stage, bring your upper limit here as 2, the lower limit as a negative what? As negative 3. Okay. John, how are you? Okay. So we are going to write the way it is, this expression inside, as 4x minus x cubed. Okay. So this time around we're going to use the upper limit, then minus the same expression which is 4x minus x cubed. Then this time around we're going to use the lower limit, which is negative 3. Cool. Negative 3. Then substitute what? What you are given here, where there is x. So this side we're going to substitute wherever there is x with what? With the 2. So this will be 4 multiplied by 2 minus this x is what? Same 2 to the power 3 minus 4. This time around x, we're going to substitute with the lower limit, which is negative 3. Negative 3 minus negative 3 in brackets here to the power 3. Okay, like this. I've just substituted. Let's now calculate. Okay, so 4 times 2, this is 8, minus 2 to the power 3. It means multiply 2 times 2 by itself 3 times, which is just 8. Okay, oh, so this is giving us 8 minus 8. All right, if you're not sure, use a calculator. That's why this is paper 2. Don't stress. If you have just joined, guys, tell me where you are watching from. Which province are you watching from, or the country you are watching from? So we have Martin from Zimbabwe. We also have someone from Kenya. Okay, I think majority are from Zambia. So if you're from Zambia, tell me the province you are watching from. 4 times negative 3 here is negative 12. Okay, don't multiply here. Wait, just write negative, because this negative 3 is raised to the power what? Is raised to the third power. So 3 cubed, negative 3 cubed is negative 20, negative 27. Okay, negative 27, like this. Then here 8 minus 8 is 0. So just the same as you just have negative, you just cancel. Then we have this negative here. Let's deal with what is this side. Okay, this side you have negative plus negative is positive. Okay, so in bracket this side you have negative 12 plus 27. Okay, 27. So what is negative 12 plus 27? Okay, so negative 12 plus 27 is same as 27 minus 12, which is just 15. Okay, so we have 0 here minus 15. 0 minus 15. Why did you add plus 1? Plus 1. Where? Oh, we are integrating. So when you're integrating, you do what? You add 1. Okay? When you're integrating, you add 1. So don't forget, you add 1. When you are differentiating, you subtract 1. All right. William from Lusaka. So, okay, 15. Last one has found 15. Okay. Let's see if at all we are also going to find what? To find 15. Okay. So, take note that after substituting here, we substitute with negative, of which we've reached at what? 8 minus 8. Okay, remember there is still this sign. Okay, there's still this sign. When you do your calculations here, you find positive 15. You still have this sign, so minus 15. So 0 minus 15 is what? Negative 15 units squared. Okay, okay, from Namibia. Claire from Namibia. I do history, not geography. Okay? Not geography. All right. So let's go to question 2. This is question 2. You can see clearly, question 2 is where is that one? You have algebra and this coordinate geometry. Geometric progression which is sequence and series. Okay, so let's proceed to question 2. So those with history, we'll have time tomorrow where when we'll look at the Southern Africa history. Okay, Southern Africa history, one of the topics there. Okay, so question 2. We are on question 2A. We're done with the first 2 questions. So question 2A here is saying simplify 4p over 3q divided by p squared q over 6 multiplied by pq over 2. This is 2 marks. Simple. Check. Here you have division and multiplication. So where you have division here, guys, on the right hand side, you need to what? To change. Okay? The numerator becomes the denominator, and the denominator becomes what? The numerator. In other words, we do what? We reciprocate. Okay? Reciprocate. So we're going to maintain this side as 4p over 3q multiplied by the 6 will be on top here, and this p squared q will be down. Multiplied by, you maintain this side as pq over 2. Simple. Kafendela kamana kamundu. Simple but sure. Slow but sure. Now, look at this. You can now multiply direct. So let's start with numbers, group numbers. 4 times 6 times p times another p here times how many q's do we have? Only have 1 here. So times q, you're done, over, okay, over 3 times 2, okay, times p, we have 2 p's, so p squared, p squared times, we have q times q. I think I've done justice here. I haven't made a mistake. KQ, we have 2, P2. All right, fine. Now we can simplify without problem. So here, this is 6, okay? 2 times 3 is 6. So you can cancel this one and this 6. Simple. We're just remaining with 4 in terms of numbers, 4 on top. Then let's check. We have 2 p's here and 2 p's on top here. Cool. This q and this q. So down, so we have on top here, we are only remaining with 4 over q. Okay, 4 over q. Last one is saying 4 over pq. Now, where are you getting the p from? Because we have 2 p's on top, and on the bottom we have 2. So this p and this p will cancel. Okay, I mean this, we have 2 p's, and the 2 p's down here will cancel. So just remain with 4 over q. You can confirm. So that's the answer. Let's go to question 2b. Okay. Precious high, and yeah, Precious, you are correct, is 4 over q. Constance, how are you? You are welcome. If you just joined, guys, tell us where you are watching from. Constance from Ndola, thank you. I think Copper Belt is being represented. I think Copper Belt is topping this afternoon today. Okay, Copper Belt is taking the lead. Walusaka, where are you? Okay, let's go to question B. This is geometric progression. The first 3 terms of the geometric progressions are 3, 6, 12 respectively. So we have 3, 6, comma 12. Okay, the first three terms. All right. Like I told you, copper belt, I think copper belt is number one so far on today, this afternoon. Wisdom from Dollar, Precious from Kitwe. That's copper belt. Cool. Southern province is absent. Southern province is absent. Western province, I haven't seen anyone from Western province. Eastern power is absent. Okay, let's proceed. Anyway, they will join us. So we have the first three terms here of the geometric progression. The first question, we are asked to find the what? The nth term. Nth term of a GP. So how do you find the nth term of a GP? This is the formula. Is Tn is equals to AR to the power n minus 1. This is the formula. Okay? That's a formula. So what do you do? Substitute. That's all you can do. Before you substitute, take note that on the formula here, you need to have the first term. You need to know the first term, of which we are given is 3. Okay, what else here? Common ratio. Common ratio is here is T2 over T1, of which T2 is, let's get 6 over 3. 3 into 6 is 2. So the common ratio is just T2. You can also get T3 over T2. You still get 2. That's what it means when they say common ratio. Let's substitute. How about the value of n? We don't know. That's why we are asked to do what? To calculate the formula for the nth term. So this will be Tn is equals to A is what? 3. What is R? R is 2. So in brackets, we're going to substitute with what? 2 to the power n minus 1. I know there is you who is thinking of multiplying 3 times 2. We don't multiply here. Why don't we multiply? If you joined yesterday's live, I explained that you don't multiply these two, as in finding 6 to the power n minus 1. Why don't we multiply? By the way, this is the answer, right? This is the answer. Last one, you are correct. So why this is the answer? It's the same as you have, let's say 3 times 2 to the power x. You can't multiply. Okay? You can't multiply until you are done with this 2 to the power 3. Or let me just write it 2 to the power 2 here. 2 to the power 2. First deal with 2 to the power 2. That's when you can multiply here. Okay? So you can't just go direct 2 times 2. 3 times 2, 6 to the power 2 as 36. No. Okay? You can't do that. I think I've made myself clear. Let's go to the second question. Last one is ahead of time. Okay. However, there is fire this afternoon. So the second question is saying geometric mean, find the geometric mean of 96 and 384. Find the geometric mean. No problem. Call me Fred. Hi. Okay. We'll call you as Fred. All right. Let's find the geometric mean. Finding the geometric mean is the same as we have A, B, C. The geometric mean is this B here, and how this B is calculated is like this. B is equals to the square root of the product of A times C. Simple. So according to this question, the geometric mean here, let me just write GM, geometric mean is equals to the square root of what? 96 is our A, and then this one is our C. So it will be 96 multiplied by 384. 384. Okay, square root. So let's multiply what's inside there. So let's multiply 96 multiplied by 384. So this is giving me 36, the square root of 36,864. Okay, then find the square root of this number. So the root of this is giving me 192. 192 as the answer. Last one, you are very correct. Okay, that's the answer, 192. Okay, if you've just joined, guys, you are welcome to this beautiful family. All right, and if this is your first time being on this channel, consider subscribing. Okay, all right. Let's go to question 3. Okay, question 3 or 2-3 or question B3. B3 is asking us to do what? To find the sum of the first 8 terms of the progression, and this is 3 marks. Sum of the first 8 terms of the progression. What is the formula? The formula is simple. The formula is Sn is equals to the first term, open bracket, common ratio to the power n, which is the nth term, minus 1, close bracket, over r minus 1. R minus 1. Flora from Chikankata, Southern Province. Okay, that is Southern Province. All right, you are welcome. Do you do science? Yes. All right. Let's substitute. Why have I used this formula instead of the other formula? Instead of starting with 1 minus r to the power n, even here 1 minus r. Because what determines the formula I'm going to use is the common ratio. Okay, the common ratio here, we found r, we found this one. This number is greater than what? Is greater than 1, so we're supposed to use this formula. If this one was less than 1, which is like a fraction, would have used what? We'd have used the other formula. Let me just show you the first page. We'd have used this, where is that one? This one. Okay, simple. Now, okay, so since we're asked to find the sum of the first 8 terms, you're going to substitute S where there is the 8, where there is n with 8, where there is a with 3. This is the first term. Okay, 3. Common ratio we've already calculated as 2, so it will be 2 to the power n, which is 8, minus 1, close bracket, over common ratio, which is 2 minus 1. All right, then here we're going to say S8 is equals to 3. What is 2 to the power 8? Okay, 2 to the power 8 is 256. So 256 minus 1 over 2 minus 1 is just 1. So S8 is equals to 3 multiplied by 256 minus 1 is just 255. 255, simple. 255. 255. All right. Divided by 1 will be just the same. So let's multiply 256 multiplied by what? By 3. Okay, so sum of the first 8 terms, S8 is equals to 765. 765. Last one, you are correct, Precious. That's correct, yes, 765. You are done with question 2. We're done with question 2. Let's go to question 3. Question 3, you have two questions. You have these questions for set operations or sets, and this is under vectors. Okay, sometimes vectors come this way, where you're supposed to show that they are collinear. Okay, to show their collinearity. Okay, let's start with the first one. The first one here, which is 3a. 3a. Okay. 3a. This question is saying, okay. The question is saying, in a particular locality, 25 people like walking. Okay. 22 people like running, and 5 people like cycling during their morning what? Routine exercises. All right. Fine. 11 people like both walking and running. 9 people like both running and cycling. 7 people like both walking and cycling. 3 people like all the 3 activities, while 7 people do not like any of the activities. Okay, fine. What's the question? The question is saying, draw a Venn diagram to illustrate this information. Explain very well on stage. No problem. That's why I'm here. I will explain. I'll make sure that you go smiling. Sets are very simple. Sets of this nature are very simple. So the first question here, we are told to illustrate in the Venn diagram. What will determine, let's first draw the Venn diagram before I go to what determines. Let's draw a Venn diagram. It's rectangular in shape. Okay, this is the universal set. Then, the first thing is, do we have the intersection of all the 3 sets? Yes, because we are told here that 3 people like all the 3 activities. So we have something like this. The first is set 2, and then this is third set. Okay, so they have the intersection of all the 3 all the 3 sets. So what you should do is, let me use a different color here. Do I have red? Okay, I do. So the first set here is walking. I'll use W to represent walking. Okay. Then this one, the second is running. I'll use R, capital letter R. Then the last one is cycling. I'll use C. Okay. Now, when illustrating this information in the Venn diagram, guys, don't waste time. Okay. Don't waste time. We start with the intersection of all the 3 sets. Start with the intersection of all the 3 sets. In other words, let me draw another Venn diagram this side so that you understand very well. Okay. If you have something like this, A, B, C, when illustrating, you start with this part. This is called part 1. Okay? This is the first part. When you are done with this intersection of all the 3 sets, you go to part 2, which is what? The intersection of the 2 sets. This is part 2. This is also part 2. This is also part what? 2. Okay? When you are done with this, you go to part 3, which is the individual sets. Like this is part 3. This is 3. This is also 3. When you are done with this, you go to the outside. If at all you have individuals who didn't like any of these activities, we'll go to the last, which is part 4. Simple. Simple. So now, according to this, let's illustrate. So illustrating, you ask yourself, if I'm supposed to start with this, how many people like all the three activities. We have three here. Three people like all the three activities. So this is part one. You're going to write 3 the way it is as 3 indicate. Then be careful. Be very careful when you go to second part. Second part you need to subtract. Don't forget. Second part you subtract. Second part minus the number you find here minus the intersection of all the three sets. You subtract. Unless otherwise you are told that they add only, okay, which is a rare case most of the times when you're illustrating. So you go, let's start with this set. How many people liked both walking and cycling? Let's get to this. Walking and cycling, we have 7. 7 people like both walking and what? Cycling. There are 7. So what you do, don't just write 7 here, away. What you do, you subtract, okay? You say 7 minus the intersection of the 3 sets here, of the 3 sets. So 7 minus 3, 4. And you write your 4 here, okay? You indicate your 4 like this, okay? You go to the next. Let's go to those who walked and ran, who liked walking. So we are told here that 11 people like both walking and running. 11 people. So we're going to subtract 11 minus 3. Okay? 11 minus 3. You're just doing, you use your calculator when dealing with this. Don't show. Okay? Don't show during the exam. Just use a calculator. You know that 11, just punch 11 minus 3. We in the first. 11 minus 3, 8. You indicate here 8. Okay? You come to this. Those who like running and cycling were how many? Where is that one? 9 people like both running and cycling. 9. So subtract 9 minus what? 9 minus 3, which is 6. So put your 6 here, okay? Write your 6. Then you proceed. You go now to part 3, okay? To part 3, which is the individual sets. So let's start with those who walked, okay? Those who like walking. We are told that it's 25 people like walking. So check, this is the set for those who walked. So you need to add. So add 4 plus 3 plus 8, then subtract from 25. Simple. That's how we're going to get this. So we're going to say 25, this 25 minus, this is minus 4 minus 3 minus 8. Simple. Okay? Or minus 7 minus 8. Simple. Don't be on pressure. And you're going to find 10. So that at the end of the day, when you add all those who are in this set, should give you what? 25. 25. Let's go to those here are 22. So we're going to do the same. 22 minus these 3 numbers. So 22 minus 8 minus 3 minus 6. And we're going to find 5. So put your 5 there. Simple. Then cycling, how many? 15. 15 people like cycling. So we're going to do the same. Subtract 15 minus these 1, 2, 3. So 15 minus 4 minus 3 minus 6. Okay, this is giving me 2. Yes, you are, John, you are correct. It's 2. Then don't forget, we are also told that 7 people do not like any of the activities. Okay, any of the activities. So we're going to put them at the in the universal set. In the universal set. Now, in the instance where or situation where you are given the total number of people, you are given the total number of people. After given the total number of people, then you are given the individual sets. You are given this. Make sure at the end of the day, after illustrating, subtract the total number of people here from, the total number of people in the three sets from the total figure you are given. Okay, if at all you are given the total figure, so that you find the number of people who didn't participate and put them in the universal set. Cool. Let's quickly go to 2A. So this is A. The question is saying, how many people are in this locality? So here they want us to add all the people. Don't stress. In fact, don't add each number one by one. No. Just get full figure of those who walked. Like this. Let's get 7 plus. Let's get those who walked. We are 25. So 25. We're just remaining with 5 here plus 6 plus 2. Okay, instead of just wasting time adding each number here, you can get the full, either those who walked, ran, or cycled. So let's add them. 7 plus 25 plus 5 plus 6 plus 2. This is giving me 45. Okay, 45. 45 what? 45 people. 45 people. Then B, how many people like walking? How many people like walking? So, only. Like walking only. That is very important. That information is very important. So here, B, only is 10. 10, they like walking only. 8, walking and running. Okay? 4, walking and cycling. So, don't need to calculate, just 10 people. 10 people. We go to C. Question C is saying, how many people like 2 different activities only? So we have this 1, 2, 3. This is part 2. Okay? So we're going to add 8 plus 4 plus 6. What are we having? 18. We are having 18. So 18 people. Good. Yes, John, you are correct. 18 people. Then last one. What's your question? I go back to question what? 2A. You mean the question here is saying how many people are in this locality? Okay? Are in this locality. So you add all the people. We've added all the people here. 7 plus 10 plus 8 plus 3 plus 4 plus 2 plus 6 plus 5. And we found what? We found 45. Okay, that's what we did. Okay. The last one on activities. Do you randomly pick? No, we don't just randomly pick. Check. These 8 people liked 2 activities only, walking and running. That's why they are here. Walking and running. They are in this set and this set. Then these 6, running and cycling. Okay? Then these 4, walking and cycling. Don't just pick randomly. All right. B, collinear vector. Collinear vector. So here we are given the position vectors of points A, B, and C, and we are asked to show that these points A, B, and C are collinear. Okay. No problem, no problem, no problem. Our job is to solve, and this is 5 marks. Like I said, that sometimes questions on vectors come like this, okay? Come like this. What are you supposed to do when you're given such a question? Do you know that there are a lot of ways to show collinearity? There are a lot of ways. We can use coordinate geometry to show collinearity by finding the common gradient, okay? But since this is under vector, let's use vector to show collinearity. So collinearity, it means that they lie in the same line. So you have point A, let's say you have point B and point C, okay? Point C. Then check point A here. Point A is -1, -2. Point B is 3, 6. Point C is what? 9, 18. What is the first thing you're supposed to do to show collinearity? To show collinearity, guys, don't be on pressure. What it means is that vector AB is equals to a scale factor, okay, times vector BC. Don't worry. Vector AB is equals to scale factor, let's use K, okay, BC. BC. Okay, this is one of the ways of showing collinearity. AB times a certain factor should give us BC. This is what it means. Okay, this is what it means. So look at this. So point A is this. Now, since these are position of vectors, then they all have the origin. Okay, position of vectors should have the origin. Let me draw a diagram to illustrate what I mean here. Okay, and this will greatly help us understand. So if we have point O here as the origin, then we have A, we can have A here, B somewhere here, and C, okay, in any order. And this A, vector A here, just know that it means that it is OA, okay, OA, which is what? -1, -2, like this. What I'm explaining here, I think I'm also explaining for that question which usually comes in paper 1, okay, where you are just given 2 position vectors, then they'll ask you find the A, C, find the OA or what. Just know that position vector has the origin. So this A, it means OA, which is this. Okay, how about this B? B, it means vector O or B, which is 3, 6. It's 5 marks, by the way, so it's worth it. Okay, so this is OB. So C will be what? OC. OC. So here we are going to write OC. OC is equals to what are we given? 9, 18. All right, we are given 9, 18 here, like this. Simple. Now let's get back to this illustration. Okay, I said that each vector, position vector, should have a what? Origin. So OA, it means that this vector is coming from this to this. Let me use different color here, like this. OA. How about OB? Yes, from O to B, like this. What about OC? From O to C, like this. I guess you will explain clarify for me where you get k. K is a scale factor. Okay, is a scale factor. It's the one that we will use to show collinearity. Don't worry. Okay, we are going to use this. We'll get back to this. Okay, we're going to use this to show collinearity. That's what we need to do. Don't worry, don't worry, don't worry. Don't be on pressure. Hang on, my friend. So, having shown like this, what you need to do is find AB and find BC, because we need to find this scale factor. It is this scale factor which will tell us that these points are what? Are collinear. Simple. Now, we can't find the K minus us finding vector AB and BC. AB, B, C. So what are we supposed to do? We are supposed to let's find AB and BC. Simple. So, vector AB, according to this, how can you find vector AB? AB. We're going to move AO plus OB. I guess you're now understanding. You see that this is very important. Illustrating like this is very important. Okay? So, AB, we're going to move AO plus OB. So, we're going to say AO plus OB. Then, we solve. So, AB is equals to, what is AO? Check, guys. This is OA. OA is -1, -2. The opposite, which is AO, opposite, the sign will change. Okay, we are moving in the opposite direction. So if this is -1, it becomes +1. If this is -2, it becomes +2, because we're moving in the opposite direction. Okay, so signs change. In other words, if you are moving in the opposite direction, plus join. So now you join points or what? What do you mean? I can't get you clearly. Well, I can't get the question. Okay, so OB is just the way it is here. You don't have to change anything. So we're going to write 3, 6. Like this. Then add. We're going to add here. This is position vector. Simple. What is 1 plus 3? 4. 2 plus 6? 8. 8. I think I have found what? AB. What is remaining to find? BC. So this I have found. Next is to find what? Is to find the BC. Okay? We are showing collinearity. Those who have just joined, we are showing this collinear vector. Okay? So, plus K. So, yeah, we will find BC. So, BC is equals to BC. Check. This is BC. Okay? BC. BC. So, we will move BO plus OC. So, here we're going to say BO plus OC. Okay. Now, what is BC? I know what is in somebody's mind is that what if we move BA plus AO plus OC? We're still going to find the same answer. Don't be on pressure. Okay? Don't be on pressure. But this is a shortcut. So time is very important. BO. We have OB, right? So opposite BO, we're going to change the signs. Okay? So this is +3 and it becomes -3. This is +6, it becomes -6. Ni 5 marks, guys. Plus OC is just in the way it is, so don't have to change signs, which is 9, 18, like this. Okay. 18. Then last one drama setting. All right, let's proceed. BC is equals to negative 3 plus 9. Okay, negative 3 plus 9. This is positive 6. If I'm not mistaken, yes, positive 6. Negative 6 plus 18. This is 12. So whatever we are doing here, we are just trying to find AB, and BC, so that we find the value of what? K. It's the K that will tell us that these are what? Collinear. The lines are collinear. Okay? So the starting point of this is that draw a line. Show that AB is equals to a scale factor K times B vector BC. Now, this is where now the issue is. I want you to pay attention. Having found AB and BC, you get your scale factor. All right? Scale factor as what? You get this as AB is equals to K, some factor, BC. So K, is this last one who asked where K is coming from? K, let me now explain. K represents any number. It's a scale factor. It can be 2. It can be 3. If you want, you can use X. So, any number here. So, let's substitute. What is AB? AB is 4, 8. 4, 8. Like this is equals to K. What is BC? Is what? 6, 12. We're going to multiply here by K. So here we're going to have 8 or 4, 8 is equals to 6 times K is 6K. Okay, times 6 is 6K. K times 12 is 12K. No, not 12 kwacha. Okay. Then let me put them in brackets so that you understand, because some of you are very sensitive. So we're going to solve for x. First, we're going to get 4 is equals to 6K. 4 is equals to 6K. Then let's get this one as well. 8 is equals to 12K. Then solve for what? For K. So we're going to divide by 6. Okay. Even here by 6. Right. This 6 and this 6 cancel. So just remain with K is equals to, this can be reduced. 2 into 4 is 2 times. 2 into 6. 2 into 6 is 3 times. So we have 2 over 3. Okay? 2 over 3. What you should find, guys, here, whatever you're going to do here, you should find 2 over 3. The scale factor should be what? The same. So here divide by 12, K by 12. This 12 and this 12 cancel. So K is equals to, we have the numbers can go into 8 and 12 without leaving a remainder. So 2 into, is 4. 4 into 8 is 2 times over 4 into 12 is 3. You see that you found 2 over 3. Even here, 2 over 3. Okay? Therefore, this, which is this one, AB, vector AB is equals to, we found K. Scale factor 2 over 3 times B is equals to AB, vector AB is equals to 2 over 3 times BC. Okay? Since finally, you can say, since AB, okay, AB is equals to 2 over 3 BC, and they share the common point. Which point is being shared here? B. Okay, they share the common point B, okay, comma, the points A, comma, B, and C are collinear. Simple. We're done. We've shown that they're collinear. 5 marks. Any question? First stage, which first stage? First stage. You mean, check, this is the question. The position vectors A, vectors of points A, B, and C are these respectively. Show that they are collinear. The first thing is that to show that they are collinear is these two, A, B, should be equal to a certain factor times B, C. Simple. That's what I've just explained. Now here, I can't summarize. It is 5 marks and it's worth it. You can't summarize. You need to solve everything here. Summary, I think summary, what you can do, know this. You have 3 points, A, B, and C. So it will be AB is equals to a certain factor of which you need to find that factor is equals to BC. Then what you'll be doing here is to find AB and BC. How can you find AB and BC minus knowing the what? Position of vectors. You need first to know the position of what? Position of vector. This is what I drew here. Okay, this diagram. Okay, then from here you find what? AB. Because without this, finding AB is difficult. Will be a problem. Okay. So if you don't use that grammar palace, you marks will be reduced. Okay, you've already shown that they're collinear here. Okay, finding the same scale scale factor. Okay, so you need to find AB, you need to find BC, then find the scale factor using A, B, and BC, and supposed to be the same. Okay, supposed to be the same. Then you've shown that they're collinear. This is where the 5 marks is what? Coming from. Okay, I think I've spent a lot of time solving this question. We can move to the next question. Okay, I think this will be the last question because at 15 hours I'm having a physical class. 15 hours. So which question should we answer? We have question 4 and 6, question 5. So we will create a time when we will do construction of quadrilateral and the triangles, where I will explain construction at the same time. Which question should we answer? Question 4 or question 6? Question 4, there is matrices and quadratic equation. Question 6 here, there is, what's this? This is probability. Then you have pseudocode and pseudocode here, and we're asked to construct the flow chart. Which one should we answer as the last question this session? Question 6, question 6, question 6. Okay. All right. Let's answer question 6. So what you can do after this video, after this live video, you can just be at your own time, try to go through. You can also go through past papers and look for that question which also asked about collinearity. Try to solve that question, okay, on your own. That's when you understand this collinear question. All right, question 6 is saying, a bag contains 9 identical cards, 4 of which are Kuhalanjika cards, K, 3 Landa cards, and the rest are Wulela cards. Okay. 2 cards are selected at random from the bag, one after the other, and not replaced. Okay, fine. The first question is, draw a tree diagram to show all the possible outcomes. 2, what is the probability that both cards selected are of the same type? All right. Stiopa. We were created to solve problems. Okay, so here, question 6A. Question 6A, a bag contains 9 identical cards. So what you need to do first, come up with the total number of cards, of which here, this question, we are given that it's 9. So what do? We have 4 Kuhanjika card. So I'm just going to write 4K. Then we have 3L. Okay, this is 3L. Then the rest are what? The rest are Wulela card, which is B. Now the rest, what does it mean? Out of 9, we have 7. Okay, so the rest is 2. So we're going to write 2 here, so that at the end of the day, when you add, it should be what? You should have 9. Okay, 9 in total. So drawing the tree diagram, question 1, our tree diagram is going to have 3 branches. 3 branches. So the first picking, I'll draw it like this. Okay, the first card there is K, is being represented with the letter K. The second one, letter L, then letter B here. The first picking doesn't affect anything. Okay, the first picking doesn't affect anything, so you're just going to write them the way they are. How many K cards do we have? We have 4. We have 4 out of total number of cards 9. Okay, how many L cards or Landa cards? We have 3 out of 9. How many Wulela cards? We have 2 out of total number 9. The first picking doesn't affect anything. Then you proceed to the second picking. That's where the issue is. Okay, second picking, you know that the tree has supposed to have 3 branches. So this is like this. So this is K, L, B, K, L, B, K, L, B. Then we do what? We solve. So here we are assuming, this is the second picking, okay? We are assuming that the card that wasn't replaced was K, Kuhanjika card. How many Kuhanjika are we going to remain with? We are going to subtract 1. We're going to remain with 3. Okay? We're going to remain with the 3. But the total number will be affected by 1, so it will be 8. Now, if it was a kuunjika card that wasn't replaced, how many lambda cards are we going to remain with? Lambda card will still be 3, but the total number will be affected by 1. Bulela card will still be 2. Total number will still be 2, but the total number of cards will be affected by 1 because of that 1 that wasn't replaced. Okay? We go to the second branch. We are considering what? Lambda card. Okay? We are now assuming that it was a lambda card that wasn't replaced. How many lambda cards are we remaining with? Well, we're remaining with 2 of total number 8. This one, conjugate card, will maintain as 3, as 4. As 4 over 8. Okay? Then the Bulela card will be 2 over 8. Then we go to the last here. The last branch, we are now assuming that it was a Bulela card. So Bulela card out of 2 will just remain with what? 1. Just subtract 1. So it will be 1 over 8. The lambda card will maintain as what? We're going to maintain as 3. Okay? We are going to maintain as 3 over 8. Then kuhunjika card, this kuhunjika, something like that. Okay? We're going to maintain as 4 over 8. Then let's write the specific outcome. This is KK. This is KL. This is KB. This is LK. This is LL. This is LB. Okay, this is BK. This is BL. This is BB. Why am I doing this? This will help us to answer this question. Question 2. Okay, we are done with the first question. The second question is saying, what is the probability that both cards selected are of the same type? Same type. So same type, we have KK, LL, and BB. Simple. Right. So the second question, that's what we're going to do. So we're going to write KK, probability of KK plus probability of LL plus probability of BP. This is supposed to be 3 marks, right? Yes. Okay. So the first K here, we're dealing with KK. So this will be 4 over 9 multiplied by 3 over 8, like this, plus LL, which is 3 over 9 multiplied by 2 over 8, plus BB, 2 over 9 multiplied by 1 over 8. Okay, just do simple calculations here. Since you have a calculator, you can just calculate direct, but you can also reduce. 3 here, 1, 3 here, 3, 4 here, 1, 4 into 8, 2. 1 times 1 is 1. 2 times 3 or 3 times 2 is 6. Plus here you can do the same. 3 here, 1, 3 into 9, 3, 2 here, 1, 2 into 8, 4. 1 times 1, 1. 3 times 4 is 12. Plus here 2 into 2, 1, 2 into 8, 4. 1 times 1 is 1 over, this is 9 times 4 is 36, if I'm not mistaken. Okay, 36 So I'm going to write 36. Okay. Common denominator here is 36. The highest common multiple, so 36. How many times does 6 go into 36? 6 times. 6 times 1, 6. Plus 12 into 36 is 3 times. 3 times 1, 3. 36 into 36 is 1. 1 times 1, 1. Is equals to, so this is 10 over 36. So this is reduced to 10 was here. 2 can go into 10 5 times. 2 into 36 18 times. So the answer here is just 5 over 18. Is it 18? Okay. Yeah, 18. So this is the answer. 5 over 18. So we are done with 6A. Let's quickly answer the last question here. This is the pseudocode we are asked to come up with a flow chart. No problem. Okay. Okay, I'm running out of pen papers. Okay. Study the pseudocode. The following pseudocode. Okay, simple. Construct a flowchart corresponding to the pseudocode. No problem. So, this is question 6B. Study the following pseudocode. Start. So, start, the shape is an oval shape. So, draw the oval shape like this. Okay. Then write inside start. Then this proceeds to the next program. So you're going to draw the arrow pointing towards the next step, which is what? Enter. So enter and display, they have the same shape, which is what? A parallelogram. A parallelogram is this shape, like this. Okay? It has both sides what? Parallel. So this is a parallelogram. It's not a rectangle, no. So this is where we're going to write enter. I need to study these shapes, by the way. Enter capital letter R, comma small letter r, comma L, like this. Then you go to the next, which is what? If r is greater than r, then, so here, this is where it's a condition. You draw a diamond shape or a rhombus, something like this. Okay, whenever you see if, it is this what? It is this shape. Now you inside here, you don't write if, you write is. You ask yourself, is r greater than capital letter R, with a question mark? Okay, with a question mark. Capital R. So if it's the question this question can either be yes or no. So here they're saying print error, the value of R is not valid. Okay, so here we're going to say, here this side, yes. If yes, print what? So we're going to have this parallelogram again. So we're going to write error, the value of R is not valid. So I'm going to first pause here. Let me first quickly end this side. Okay, now if the answer is no, that's what it means when you say else. If the answer is no here, you go to the next. Else, S is equals to. So this is an action box where you put your formula. And an action box is a rectangle. Okay, like this. A rectangle. Simple. Now inside this rectangle, we're just going to write the formula the way it is, as S is equals to pi here multiplied by, to show multiplication you put a star, okay, multiplied by open bracket capital R plus, is this small letter R? Yeah, small letter R close bracket times what? Times L. So star L. Okay, star L. I don't have a space there, that's what I've written is star L. Okay, what is the next instruction? The next instruction is end if, print S. So just going to this, print S. So print S is what? Print S is this for enter, this parallelogram. So we're going to write here print S. And if the last thing is what? Stop. Stop. So we're going to write an oval shape here. Stop. Remember here there is this error message that was what? That is need to be displayed. So this error message will just come to stop if you go to that route. Okay, so we draw something like this. Okay, then you are done with this. Then one by one the meaning of each shape. Okay, this oval shape is for what? Start and stop. The parallelogram is for decision box. Okay, this is the decision. This is where you put is so what something like this. Then action box is a rectangle. This is where now you put your formula, you calculate. Otherwise this is 5 marks. Yeah, simple. We write this way always. Yes, but it's different. It depends on the question. Sometimes you find other questions you have two actions box, 2 decision box. So but most of the times it's just like this. Okay, I think we are done. Then those who are writing next year GCE, my number is 0977570152. okay, you can text me or just give me a call on this line. All right, I'm just remaining 15 minutes. I have a class. Okay, so you can still use the same number if you want, if you need to support, because our plain paper is just here. If you just need to support, you can use the same number. We buy a ream of paper, we continue. Thank you so much. May God bless you as you prepare for your final exam. See you in the evening. In the evening we'll be looking at paper 1 or biology. Okay, mathematics paper 1 or just biology, whichever. Thank you so much.